Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 170. The title is You're Thinking About Agent Authorization Wrong. Our guest today is Jacob Moshenko, co-founder and CEO of AuthZed. Welcome, Jacob.
Hi, thanks for having me.
Um, awesome. So before we dive in, maybe you could just tell us a little bit about your career trajectory.
Sure. So I studied computer engineering, which is kind of a surprising thing for a founder of a software company. After that, I went out to Seattle to work on airplanes for a little while for an airplane company you may have heard of. That's sort of like my first act. But while I was out in Seattle, I got the software bug and started working for Amazon. And that was really my introduction into web scale and web technologies and how to architect these massive distributed systems. Did that for a while, then went out and came out here to New York and worked for Google for a little while. At Google, I was working on API infrastructure. So the infrastructure behind all of the APIs that you may be interacting with Google services using. And then after that, I sort of got the entrepreneurial bug. So it went from like airplanes to technology companies to entrepreneurship. And then around 2012, left Google to start a company with one of my Google coworkers. The original idea that we founded the company with never took off, but we did create a product as part of that called Quay. Quay was the first private Docker registry in the world, even before Docker Hub let you upload private images. So we did that for a little while. We ended up selling that to another startup called CoreOS, continued to do the CoreOS journey through its conclusion, where we were acquired by Red Hat, and then Red Hat was acquired by IBM. So we went from a 2-person company to a 400,000 person company. And if you've gotten bitten by the entrepreneurial bug, a 400,000 person company is a tough pill to swallow. So then we left and started AuthZed. And we've been doing AuthZed for about 5.5 years now.
Awesome. So before we dive into the topic today is I think going to meander to agentic authorization. But before we do that, maybe we could just talk a little bit about SpiceDB. My first question is SpiceDB a database or an authorization engine, or maybe a little bit of both?
Yeah, so SpiceDB is an authorization engine. That's the way to think about it. The reason that we call it SpiceDB instead of just maybe like Spice or Spice Engine or something along those lines is the paradigm that we've chosen for authorization is one of centralized authorization, where all of the data is aggregated and known by the authorization service ahead of time before you make a request. And so what that means from a practical sense is that the application is constantly updating SpiceDB with facts and information about how people are related to other people, how data is related to other data. And so you're constantly writing into this authorization service. And then when you want to make a decision, you just ask the service, right? Like, for this user trying to do this thing, should they be allowed to do it? And because it has all of the context and all of the data ahead of time, it can say yes or no very quickly. And so what we found out is that people who are used to policy engines as a working paradigm for authorization were confused about the concept that they had to write data into the service and that they had to integrate it with their application to bring all the data over. And so to sort of sidestep that whole issue, we just slapped a DB on the end, and then people were like, oh, I get it. I have to write data, and then I can do queries and get back permissions answers very quickly.
So one of the ways that I think about graph databases is almost like database indexes. Like when you update the data, you update the index, and the index always has to be in right and in sync with the database. Do you think that that's an inaccurate way to think about it, or that's a reasonable way?
So run that by me one more time. When you think of a graph database, you think of it as an index?
I think of a graph database as sort of like a database index. Um, so the index has to be up to date and in sync. And an index is like it's a way that we're going to use persistence to get a quick answer, because we've already sort of recorded or pre-calculated like that query, and all we have to do is grab it off the disk and return it. So I don't know. In my mind, I always think of, I've been thinking about graph databases sort of like a database index.
Yeah. That definitely doesn't match my operating definition. I won't come out and say that it's wrong before I give it the due thought that it requires. The way that we're using the concepts of a graph database to figure out authorization decisions is we're keeping all of those relationships I was talking about earlier, right? Like Mike is the founder of Glue and Jake is the founder of AuthZed, and Glue and AuthZed may have a partnership or something, right? Like I'm thinking of those things as directed, like edges in a directed graph.
Mm-hmm.
And then we can think about authorization decisions as graph traversals, right? Like, can I find a path from Jake, the actor, to the thing that Jake is trying to do, right? Like Jake may have admin on some doc, and therefore Jake is allowed to write to that doc. So I'm just walking the graph. And the way we do it is not, in SpiceDB, the way we do it is not pre-computed. So it's, we're walking those edges, we're collecting up edges and we're walking them in parallel as we find them. And then eventually when we find a solution to the graph query, we say, yes, Jake is allowed. And if we fail to find a solution, we say Jake is not allowed. What you're describing though about pre-computing in an index is very similar to a service that we've built at AuthZed called Materialize, where we actually go and we take the entire complexity of the graph, right? Think of a massive spider web. And we compute it down to the ends, the different endpoints of the graph, right? Who specifically has access to what? And that gives us some great primitives to be able to traverse the graph faster and also answer questions like, what are all the documents that Jake has access to? And for this document, who are all the people who have access to it? It gives us sort of these like list and iteration operations.
Interesting. So the way you're describing it is that the authorization relies on graph traversal at decision time. And I'm wondering, are there certain types of problems that lend themselves to that solution?
Yeah, absolutely. I think the important part is the idea that there is what I call this ambient context about how things are related to each other that exists outside of the scope of a single request that you might be getting, right? Like if you get a request, it's an HTTP GET request for the contents of some document. Okay, wonderful. At the outset, I know what's the identifier of the document. I know the identity of who's making the request, potentially based on an authorization header or something along that line. And based on the verb, I can kind of guess what they're trying to do. We're trying to fetch the contents, we're trying to change the contents, etc. But what I don't know is the existing relationship that existed before the request around what is that person's access level to the document. Do they belong to a team that has some access to the document? So these human-like or these federation constructs that we build for products that are very human-like end up following the structure of a graph, a directed graph, right? So what I mean by that is when I say like, you and I have now spoken, you and I have a relationship. We could record that in the graph, and then we could make an authorization decision about, whether Mike and Jake have ever spoken before. That ends up following, like that looks like a social graph more than it looks like a set of rules in a computer program. So all of these kinds of problems where we have that ambient context where things are related to each other in sometimes mysterious or interesting ways, we can record that all into the graph, and then we can just use that graph directly to make our decisions. Did that make sense?
I think it does. It does to me at least. And so I want to ask actually the converse question. So if this is the directed graph is good at this type of problem, what types of problems is it not good at?
Yeah, we tend to direct people over toward things like policy engines, things like Open Policy Agent or Cedar, when you have all of the context ahead of time, or it's very easy to get to. So an example of that would be if you were trying to build like a HTTP appliance or a firewall or something, where all of the data that you need to make decisions can be pre-encoded or can be built into the rules and can be gathered from the request itself. Those can make decisions very fast, like microseconds, for example. But it's because they're not having to go and fetch the data. But as soon as you violate that, those bounds, as soon as you need data that's not being presented to you, like on sort of a silver platter, you have to go and talk to a database and fetch that data and use it as context for those policy engines. And that's where you can run into some of these, your request will only be as fast as your slowest database, that kind of thing. So that's kind of where we draw the line. It's like if everything is available at the ready, at your fingertips, policy engine all the way. If this context exists and it mutates rather slowly and it exists outside of the context of the request, then I think that this directed graph approach tends to fit the problem better.
Interesting. Yeah, I would agree with all that. Okay, let's pivot into authorization or agentic authorization. I liked your description of the episode. You mentioned something to the effect of that our current underlying protocols offer little guidance on authorizing agentic authorization. What's the status quo today? What do you see today in the market is happening with agentic authorization?
Yeah, I want to get your take on that as well, because you host a lot of these things. You've talked to a lot of various people, as have I, right? And so I'd like to compare notes. But what I see as the state of the art for agent authorization can be broken down into a couple of different paradigms. One of the paradigms is the agent acts as me. We call it like the personal assistant agent. And
Actually, can I pause you for 1 second?
Yeah.
I wanted to do a quick, I don't do a lot of screen sharing on this thing, but actually I have a screenshot that I was going to show. And it actually shows, this is a screenshot from a video from Entro Security. And it shows exactly what you're talking about. So in this scenario, an agent, a ChatGPT agent has been created. And there's a human in here. Peleg Cabra is the human. And Peleg Cabra has basically given its permissions to all sites.read, files.read, user.read. So the way that I read this is that when the agent, let's say this ChatGPT agent is interacting with ChatGPT, it's impersonating this human and it's inheriting the permissions of that human in the end application. So is that sort of what you're talking about?
That is my assumption. I don't know the particular product that this screenshot comes from, but my assumption is that you can potentially attenuate that human's permissions. Mm-hmm. So you say when ChatGPT impersonates Peleg Cabra, they can do everything that Peleg Cabra can do except, right? And we call that attenuation. That is sort of like the second notch up the ladder of what I'm describing. But the first notch is the agent can literally do anything that I can do. And a great example of this would be like when you run Claude Code on your desktop. Whether you think of it that way or not, Claude Code is a personal assistant. It's helping you code more quickly, right? But Claude Code also has full access to the context of your laptop. Bar some people who may run it in like a container or something like that. Most people are just running the application right there on their laptop. And Claude Code can run RM across your whole code base. It can do Git commands. It can open up web browsers if it wanted to, right? Like the number of things that Claude Code can do from that context is vast. And it's doing it all as you, right? So when it does one of those things, it's going to look like Mike tried to delete the whole code base, or Mike tried to fire somebody, or Mike tried to do that, right? And so that's the first paradigm, which is like the agent is just me. And that fails in really obvious ways, right? Like you don't want a coding agent to be able to make transactions in your bank account, for example. And so that's just the first paradigm that we think of. And the other paradigm is like these agents are getting built into companies' infrastructures and becoming part of their digital workforce. And that I think is maybe what you were just showing, where you're like maybe impersonating an individual, or maybe you're granting the agent its own identity and assigning authorized actions to that identity, right? So like you could create an agent and you could call it Agent Smith, And Agent Smith is only allowed to do these 3 things, and those are the 3 things that we think Agent Smith should be allowed to do in order to get its job done. So these are the paradigms. What I'm seeing from a technical perspective is really kind of all over the place, right? I'm seeing people try to isolate agents using containerization technologies. I'm seeing people try to isolate agents at like the tool call layer, right? When the agent actually reaches out and tries to touch the world. I'm seeing people try to isolate agents with all-in-one platforms, right? Where the agent gets its identity and all of its permissions and it takes all of its actions through this one single platform. Like and especially because I live in the startup world, I'm seeing all of this stuff come. And I'm not sure I'm actually sold on any of those models, but I'd like to turn it over to you. What are you seeing? Are you seeing the same things?
Well, so I recently wrote an article called No, Your MCP Gateway Won't Solve Agentic Security, because I can't tell you how many MCP proxies I've seen. Um, I actually have props. I have MCP. This is my MCP server, and this is my agent. Um, and so the MCP server is in the data center. That's why it's a penguin. And this is my Bucky's. And so so we have these two guys talking to each other. And somehow a lot of people think that the MCP server is somehow this panacea where they can put in an MCP server proxy that will sort of filter all of their MCP traffic and enforce security and enforce identity. And then they somehow think that that's going to deliver zero trust. My position is that we are lacking the agent identity layer. So we don't know how to actually, what's the life cycle for an agent to obtain an identity? What identifier do we use and what credentials and what claims do we use? So we're missing the agent identity layer. We don't know what tokens to issue. We don't know what flows to actually obtain those tokens. We don't have adequate ability to express policies about the tokens that we're seeing downstream. And we don't have the ability to set up the trust relationships between the organizations to say which claims of which tokens do we trust. So from my very skeptical perspective or cynical perspective, there's no infrastructure at any part of this whole ecosystem that would give me any type of confidence that we've really gone through this digital transformation where we have it solved. So I'm extremely cynical about this, and yet we see MCP proxy after MCP proxy being offered as a magic bullet solution. And in my article, I said, no, your MCP proxy won't solve security, just like your web gateway didn't solve web identity or web security. Your MCP proxy is not going to support solve agentic identity or agentic security. So that's my take on it.
Do you think that's inherent to the idea of an MCP proxy? Or do you think that a sufficiently smart, better mousetrap could be built that did enforce all of those things at that layer?
I'm not anti-MCP proxy in a weird way. I like web gateways too. How many web gateways are there out there, like Nginx and Envoy, and really good ones like Solo.io and Tyke and Kong? And so there's a lot of, tactically, I think my issue isn't that an MCP gateway is bad. Actually, your worst case scenario is a bunch of one-offs. So to the extent that an MCP gateway can give you operational leverage over policy and filtering could be a good thing. But I just feel like in a large enterprise, will always be true that there'll be multiple gateways, probably multiple standalone services also. But just thinking about it, going back to my props, the MCP server has a identity. The agent has an identity. These are two different identities. Also, there's a lot of downstream services, especially when we look at the data layer. So if we're going to introduce zero trust, actually the database has a machine identity too, or has a software identity, because it's making decisions about what data to return, which could be really critical. And so I just see MCP servers as part of the plumbing, not necessarily bad, but completely overhyped in terms of solutions for agentic identity.
I 100% agree. I think the direction that we need to go is that the actual tools that the MCP is talking to, like the backing services, right? The SaaSes or the databases or whatever, they need to be able to authorize the actions that the end user communicating through the MCP is allowed to actually take. To me, I see the MCP as an interesting choke point for attenuation, right? So if you're making a request through an MCP server, it might say like, oh, making this particular tool call at this particular time doesn't really make a lot of sense. But ultimately, it needs to be passing through the identity of the agent to the actual backend services. And those backend services themselves need to understand that agent identity and make their own decisions about whether this is a real thing they should be allowed to do or not. Right. And that's a stance that I think at AuthZed we're well positioned to sort of put forward and bring into reality, because we're talking about, again, that ambient context, how these things are related to each other, and how the software is built to leverage those relationships and make authorization decisions based on those relationships.
What do you think is the control plane for authorization? And also, so I feel like in the old days we had RBAC, and RBAC was not very expressive, but was easy to govern in a way, because we could say, these roles had these permissions. We review the roles and who has the roles. And there was sort of like an implicit enterprise solution for managing RBAC, as limited as it was. If we're saying that, okay, we now have more expressive ways that you can control security using graphs, what's the control plane so that we actually know that we have the right number of policies or enough policies?
Yeah, this might be a time to talk about sort of traditional IAM versus CIAM. So what we're focused on is building authorization into great products, right? So imagine doing the authorization for something like Turo or for something like ChatGPT, right? This is a product that's end user facing, versus traditional enterprise RBAC is usually about protecting or making sure that the first party employees of a company have access to the right underlying services. Now, at scale, that second use case starts to look like the first use case. But where we see the control plane for authorization living, and if we sort of take a step back from millions of services and hundreds of users and think of dozens of services and millions of users, which would be the more like customer facing IAM, the control plane really ends up getting built directly into the products themselves, right? So we can do clever point-to-point sharing things, we can do graph things, we can do all these ambient context things from the perspective of the application itself is governing the authorization as part of the experience of using that application. Now, when we think about AI agents and AI authorization, that is a product, right? Like that has to deliver a great authorization experience. And so I think the control plane gets built sort of bespoke for how you want to limit agents and what they're doing. And each application has to have a concept of what an agent is and may be able to make a decision, right? Like if you're at an enterprise and you have a document sharing service and you have a receipt management service, those two things may have a completely different view of what an agent is allowed to do within the context of that application.
One of the rabbit holes that I feel like I go down with every agentic conversation is this idea of non-deterministic input. So the question could be, who's the highest paid employee at IBM? And your LLM is now connected to your, let's say, internal Google Sheets and could actually figure this out. How do you go about actually putting controls on when these traditional enterprise workflows were so static? Did I have this access in this application? But the questions about access could be so much harder to predict. What are some of the new challenges, and how could we possibly write policies about those types of things?
Yeah, I'm actually glad you brought that up because this is exactly the problem that we're helping OpenAI solve for ChatGPT Enterprise connectors. So they do the very thing that you're talking about, right? You attach your enterprise Google Workspace to ChatGPT Enterprise, and then it siphons down all of the information that exists in that enterprise, right? And so now you open yourself up to interesting issues like who is allowed to access this spreadsheet. But the interesting part here is that Google Workspace already knows who is allowed to access that spreadsheet, right? And so what you end up doing is when you bring down the information to store it in your vector database, you can also bring down the authorization information and store it in AuthZed. And now at prompt time, when the person says who's the highest paid employee at IBM, that is now getting matched against documents that may contain that information. And then it's getting filtered based on the person who submitted the prompt. Are they actually allowed to access those documents? And we're eliminating all of the documents that they shouldn't have been allowed to access and only using the documents that they should be allowed to access. And it may or may not contain the data that they're seeking, right? Does that make sense?
Yeah, but it seems like it also, so part of the responsibility here is that the end application, in this case, Google Sheets, has to know who's allowed to, and Google does a good job at this. And it also has a very graph-based approach. But let's go back to SharePoint, and where I showed this screen point where SharePoint is a more traditional, CMS application, and more RBAC-y, where so so what happens with all of those applications that, let's say, aren't using an authorization syntax, or I don't know, do you just not connect those applications into your AI? Or is there another way to reason over it, or make policies about it?
Yeah, the neat thing about RBAC is that it's a 100% subset of relationship-based access control, which is what we're doing. So you can model any RBAC system using relationships in a graph. So in that case, like that was kind of a softball because you can totally recreate the SharePoint authorization logic in something like SpiceDB using AuthZed and use that same process that we talked about for Google Workspace. If we talk about something that is more policy-based, though, where they say like, access to this thing is only accessible to these IP addresses or only accessible on Tuesday or something like that, then you're going to need something that can understand those primitives and can enforce those decisions. But I think the underlying assumption that those upstream services still have their own way of protecting that data. And just because you've brought that data down into a secondary service, like a data lake or like a vector DB, you're still going to want to endeavor at every possible point to respect the authorization that was set up in the upstream. Because that's what the users who are federating that data at an organizational level, that's what they're reasoning about. That's when they say like, all right, I'm going to share the top 100 salaries spreadsheet with this group at IBM. They're making that decision at that time and sharing it at that level. And you want to try to respect that and enforce that wherever that data may end up getting used and consumed.
Yeah, it seems like we potentially are set up for a confused deputy problem, where if the agent is acting, and then here we get down to the identity layer, but if it's acting on your behalf, or even worse, if it's using credentials maybe with more permissions than your permissions and can pull down spreadsheets, ultimately, wouldn't it make sense to move the permission layer as far back as possible into the data, so that you would say the database shouldn't even release this data, like let alone so that the agent can't be confused and return the wrong information. So where do you see enforcement being utilized in the infrastructure?
Yeah, that's a great point. The ideal would be, like I said at the outset, the ideal would be that each service was limiting the access of the agent itself, right? So in this particular example, it would be Google Workspace is limiting what documents the agent can see natively. The trick or the problem there is the speed at which AI agents operate and the speed at which systems that we've knitted together like RAG operate you wouldn't be able to go to the Google API document by document and say, does this agent have access to it? It's just not fast enough, right? So what they're doing, what OpenAI is doing, is recreating the authorization system of Google Workspace on their side so that they can do it at scale and at speed. Now, what do I see the ultimate eventual world looking like here? I see agents being a thing that I can talk about in Google Workspace, right? And I can say, share this document with this specific agent that has an identity. Or share this document with this user group, which may be populated by half humans and half agents, but it doesn't matter, because at the end of the day, the prompt that's being submitted or the action that's being attempted is being done on behalf of an agent, and we're mapping that back to the actual authorization as it exists in the upstream. I think we're a long way away from that. Like you said at the beginning, I don't think we have the right agent identity frameworks, right? Like I can't go into Google today and register a new user and say that this is a non-human identity and I want to start sharing documents with it. In some services, you certainly can, but not all of them. So I think what we want to see is we want to see that paradigm find its way into multiple products, or all of the products that the agents are reaching out and actually communicating with. And you're absolutely right. Any attempt to do that at a middleware and say, like, we're going to limit down the scope of what this agent is able to do is going to be subject to confused deputy, and it's going to be subject to constantly trying to iterate and understand how the way those APIs are structured is being changed to try and keep up. And so I really do believe that it has to be done natively in the actual upstream services or the sources of the data.
Niccolo Gallo he is a sort of a startup entrepreneur, and he's proposed a new mechanism for conveying information end to end, because the communication itself, so if we don't understand the integrity of the information from the point at which it's delivered all the way to the end, it becomes very difficult. So how do we know, for example, that the token wasn't stolen somewhere and represented? So in OAuth, we have this idea of like Depop, where we can do a proof of possession between point A and point B, and we can say, well, I can tie this token to a proof of possession of cryptographic material, so I can show you only I could have presented you this token. But then when you try and to use that trick downstream, it sort of falls down, because proof of possession only goes really between, in one step. And so a lot of this challenges, it seems that we have, are trust challenges, where we're trying to convey information over multiple domain boundaries. So the agent talks to an MCP server, which invokes a tool, which calls a database, or which calls an API, which calls a database. And so downstream of the MCP server or the agent is where a lot of these policy decisions are relying on the assertions made or presented through tokens that were acquired. Do you see, what are some of the challenges that you see in the trust area? And is it, a lot of people will say, oh, we need OBO tokens, on behalf of tokens, but really, like, where is this falling down, and is this even a solvable problem?
Yeah, that's a that's a can of worms you just opened. A lot of the research for how we think about some of these things has come from Google, as Google has sort of grown and expanded and run into the pitfalls of some of these things, right? So two sort of like at their outset competing ways of thinking about authorization have both come from Google, right? They created the idea of macaroons, which are signed tokens that can be layered and have additional assertions and attenuations and applied to them. So that would be a way where you could like pretty strongly do like an on behalf of concept. And then the thing that we're based off of is the concept of Zanzibar that also came out of Google, which is keeping all of this context, this ambient context, in a centralized place, and then making your decisions as close to the leaf, the point of actual access, as possible. And I think with combining these concepts, you can get a cohesive vision where you have an actual end user identity, right? And that could be an agent, that could also be a human, like a non-human or a human identity. And then that's passing through, as you say, MCP proxies and API layers and databases and things like that. But each time it passes through something, they could layer on an additional claim. Like, I am so-and-so, and I hereby assert that I'm passing on this token. I'm cryptographically signing that fact. And then that gets all the way to the end service, who does verifications on one or more of those layers and extracts the actual identity that is the origin of the request, right? Like, be it an agent or a human, and then matches that up against the data that it's trying to access and makes a yes or no decision based on all of that data that exists in that permissions database, right? So that would be sort of my vision. I am very much against the ideas of like JWT tokens that include a list of everything that you have access to, because you end up with like 5 megabyte JWT tokens. And yeah, you can attenuate them with things like macaroons, but they're still way too big. There's size limits, they're slow to transmit, and they're quickly out of date. So I strongly believe that you want to push the actual authorization decision as close to the physical access of the data as you can. Does that make sense? Is that a compelling vision?
Yeah, and I agree that you don't want to put a lot of data in JWTs. They should be just need to know. Like a good example of that is, don't put all the group memberships of the person, like just put the ones that are needed, because all the group memberships might be oversharing. And we see there's a lot of bad ways to use JWTs. So I think part of the challenge here is that there's a lot of the list of ways you shouldn't use JWTs is infinite. There's a lot, but there are actually some good ways to use JWTs too. So you have to figure out how to, and the OAuth group has a lot of guidelines for best practices. And if you listen to all the guidelines, I think you'll be in good shape. But yeah, there's a lot of gotchas in there too. I wanted to point out, actually, Cell came out of Google also, Common Expression Language.
And we use Cell to do our caveats work in AuthZed. So we brought a very small amount of attribute-based access control and brought it into the reback model, into our model, the graph-based model. And we use Cell to basically turn on or off an edge in the graph based on a set of attributes that may or may not exist. So like we've read all of this stuff, we've digested all of this stuff, and this is what we've come up with as the sort of least subject to mistakes way of protecting data, which is to put the actual access control decisions as close to the data as possible. You mentioned putting groups in a JWT. In my opinion, the JWT should prove one thing and one thing only, which is who is the identity of the bearer of this JWT. Because even when you start putting groups in, what if a person was revoked, had a group membership revoked 2 milliseconds after you minted that JWT? So under our model, under the reback model, the group membership and the way you access the document through that group membership is computed all the way at the end at the data access and will be as fresh as whatever changes happened in between that JWT minting and the actual data being dredged out of the data source of the database.
There's a lot of different types of JWTs today. JWT isn't an OAuth standard. It's in a separate group at IETF. And we use JWTs like for everything now. Like federation tokens are JWTs. FIDO assertions are JWTs. There are profiles for verifiable credentials that are JWTs. So JWT to me just means it's a signed JSON. And so, but it could be.
Yeah, I should have been more specific. Where I'm talking specifically about an identity token. And often the next step when you have a JWT representing a person's identity is like, okay, now let's put in there what they can do. And that's what I think the fatal mistake is trying to bind this idea of like, here, I have something that pretty concretely tells me who I'm talking to and making assumptions about what they can actually do. Like I say, those things are overly broad and they're often stale. Like they're overly broad in terms of both time and scope.
And to be fair, OAuth access tokens, which are Not sure what happened. Oops, not sure. Oh, okay, sorry. Let's start that again. So access to OAuth access tokens, which are not identity tokens, um, they normally have scopes, right? And to be fair, my definition of scopes in English was extent of access. So it was a way for an OAuth authorization server to give a client a token where it could say, I have this extent of access to call these APIs. Scopes are normally tied to methods and endpoints in APIs. But so to be fair, a lot of people are looking to OAuth tokens for authorization. It's called an OAuth authorization server, not an identity server. And but somehow it seems like what we're seeing is that the use cases for authorization have way exceeded the original design, which was more about delegation. I'm going to delegate this application to be able to see my calendar. So I'm going to give it calendar.read, right? So I think in these easier use cases, there was a one-to-one relationship, but now the policies are getting more complicated, and the scopes are insufficient for expressing that policies. But do you have any other ideas about scopes in particular?
Yeah, I'm glad you brought up scopes, because I think people think of scopes as a right to access something. But what scopes actually are scopes are an attenuation mechanism. So if I'm presenting an OAuth token for, let's say, GitHub, for example, if I present an OAuth token and it says, this is Jake, and Jake has granted repository.read, right? It does not give me access to read every single repository at GitHub. It only gives me access to read the repositories that I have access to. So what we're doing is we're starting with the global view of what Jake can do, which is already being enforced at GitHub based on a mechanism similar to a policy engine or an authorization engine like SpiceDB. So it's taking that global view of what I can do, and we're attenuating it down based on what I've decided that this particular application should be able to do to my data on my behalf. So it isn't a positive grant. It's not making any positive assertions. This thing should be allowed to do X. It's saying this thing should be allowed to do at most X. And it's the intersection of what I can do, my identity can do on the GitHub service, with the scopes that I've chosen to grant to this particular application or agent or whatever I'm delegating that access off to.
Okay, the pigeons are flying. It's telling me we've hit the end already. So before we break, any last thoughts?
Yeah. Just before this talk, I was actually on a live stream where I presented a talk called "Falsehoods That People Believe About Agent Authorization." It's a more structured version of what we talked about here today. We're a little bit slower to edit our videos, so it'll be a while until we get it up on our YouTube, but I highly recommend that people check that out in terms of seeing like a, sort of a scripted form of what I think about this space. My key takeaways for people to leave this chat with would be, you want to do your enforcement as close to the data as possible. And you want to make sure that you're thinking about agents as their own identity. And you're thinking about, how can we possibly get to a world where I'm sharing things specifically with agents? Because that's going to be the paradigm that unlocks us really allowing agents to go off and do things. Any sort of attenuation or impersonation is always going to be subject to the continued access that I as a user actually have, and therefore is going to run into some digital workforce limitations that we're just not thinking about, because we're so early in this journey of AI agent adoption. And authorization, as it is with application development, is always going to be one of the last things that people think about. So I encourage you to really think about it through a different lens.
Nice. And so the authorization conversation will continue next week with Phil Winley, the co-founder of IAW. Many people will know him for that. He's writing a new book with Manning called Dynamic Authorization. It's out for early access. They call that MEEP. I forget what it stands for, but basically you can read it online, whatever chapter he's written. So we're going to check in with Phil And yeah, I think that's it. So I guess, Jake, thank you so much for being on the live stream. Audience, thank you, and we'll see you next time.
Thanks for having me. Bye.